projects. In this video, we are going to explain about a project titled A Hybrid Intrusion Detection System based on Feature Selection and Weighted Stacking Classifier. So now coming to the introduction part. In the modern, highly interconnected global landscape, safeguarding the integrity of computer networks and systems stands as a top priority. Intrusion detection systems, that is IDS, which plays a pivotal role in the identification and mitigation of cyber threats. A central issue in the realm of intrusion detection is the precise and timely recognition of malicious activities, all while keeping false positives to a minimum. To tackle this challenge, a fresh approach has surfaced: an advanced hybrid intrusion detection system that amalgamates feature selection methods with a weighted stacking classifier. The groundbreaking system is designed to elevate the accuracy and efficiency of intrusion detection by harnessing the strengths of both feature selection and ensemble classification. So now coming to the objective part for this project is to substantially boost the effectiveness and efficiency of detecting intrusions within the computer networks. Enhanced detection precision. The primary objective is to elevate the precision of intrusion detection. Through the utilization of feature selection techniques, the system concentrates on the most pertinent data attributes, thus diminishing false positives and improving the accuracy of identifying malicious actions. Second, here we have this decrease in false notifications. A crucial aim is to reduce the number of false notifications generated by the conventional intrusion detection systems. So now coming to the requirements part, here we have two types of requirements, that are hardware requirements and software requirements. In hardware requirements, operating system as Windows is required, processor i5 and above, minimum 8 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirements part, Anaconda 3 is required and Visual Studio Community version is required. So now coming to the flow of project. Here first we have importing the packages. In this module, necessary libraries and packages which are NumPy, Pandas for data manipulation, sklearn to facilitate machine learning, and matplotlib and Seaborn for visualization are important. Then next here we have exploring the dataset. In this step, you are examining the dataset to get a better understanding of its structure, content, and characteristics. You might look at basic statistics, data types, and sample records to inform your analysis. Then we have data processing using Pandas data frame. Data processing includes cleaning and organizing the data using Pandas, a Python library specially designed for data manipulation and analysis. You might handle missing values, format data types, and restructure the data as needed. Then we have visualization using Seaborn and matplotlib based on different column data. This step involves creating visualizations of your data using Seaborn and matplotlib, which are Python libraries for data visualizations. You may generate various plots and charts to better understand your data patterns and relationships. Then we have label processing, label encoder from object to int. Label processing involves converting categorical labels, example text labels, into numerical label values using a label encoder. This is often necessary for machine learning models that require the numeric input. Next, we have feature selection algorithm. Feature selection is the process of choosing the most relevant features or attributes from your dataset. This step might include using a correlation algorithm with decision trees to identify the most important features. You may create separate datasets X and Y with and without these selected features. Next here we have data splitting into train and test. This step involves splitting your dataset into two subsets, a training set and test set. The training set is used to train your machine learning models, while the testing set is used to evaluate their performance. Next here we have building the model. Here you are creating machine learning models to make the predictions based on your data. We mentioned building models with feature selections and with all features including various models such as random forest, decision tree, k-nearest neighbors, logistic regression, a voting classifier combining k and n, random forest and decision tree, XGBoost classifier, AdaBoost, SGD classifier, a stacking classifier comprising random forest, SGD and LR, and a weighted stacking meta classifier which consists of random forest, light, GBM and MLP. Next here we have training and building the model. This step involves training the machine learning models with the training data, allowing them to learn patterns and relationships in the data. Once trained, the models can be used to make the predictions or classifications based on the new or test data. Next here we have importing the packages. In this step, you import necessary Python libraries and modules that are essential for this project. This package provides various functions and tools required for the data analysis, machine learning or application development. Then we have exploring the dataset. This involves a comprehensive examination of the dataset to gain a better understanding of its content, structure, and characteristics. You might look at data statistics, data types, and sample records to inform your data analysis. Then we have data processing using Pandas data frame. Data processing is performed using the Pandas library, which is specialized for data manipulation and analysis in Python. This step includes like data cleaning, handling missing values, and formatting data for analysis. Then we have visualization using C1 and Matplotlib based on different column data. In this step, you create visual representations of your data using Seaborn and Matplotlib, popular Python libraries for visualizations. You can generate various charts and plots to visualize data patterns and relationships among different columns. Next, we have label processing, label encoder from object to array. It involves converting categorical labels, often in the form of text, into numerical values using a label encoder. This conversion is typically necessary for machine learning models that require the numeric input. Next here we have feature selection algorithm. It is a process of choosing the most relevant features or attributes from your dataset. This step might involve using a correlation algorithm with decision trees to identify the most important features. You can create separate datasets X and Y with and without these selected features. Then we have data splitting to train and test. You split your dataset into two subsets, a training set and a testing set. Training set is used for training the machine learning model, and the testing set is used to evaluate the model's performance. Next here we have building the model. In this step, you create machine learning models for prediction or classification. You mention building models with feature selections and its features including random forest, decision tree, KNN, LR, a voting classifier combining the KNN, random forest and the decision tree, XGBoost classifier, a DABoost SGD classifier, and a stacking classifier comprising of random forest, SGD and LR, and a weighted stacking meta classifier consisting of random forest and light GBM and MLP. Next here we have training and building the model. It is similar to the previous step, which involves the training the machine learning models with the training data, which allows them to learn patterns and relationships in the data. Then we have Flask framework with SQLite for sign up and sign in. You implement a web application using the Flask framework and the SQLite database for your user registration and authentication. Flask is a Python web framework and SQLite is a light-based relational database. Then we have importing the packages, similar to the step earlier which we have studied. This step involves importing the necessary Python packages and libraries, potentially for a different part of the code or a separate script. Next here we have user gives input. User provides input which could be in the various forms depending on the application's requirement. Next here we have the given input is pre-processed for prediction. The user's input is processed or pre-processed, which may involve tasks like cleaning, formatting, or translating the input into a suitable format for the prediction. Next here we have trained model is used for prediction. The machine learning model which has been previously trained is applied to make the predictions and provide responses based on the pre-processed user input. And the last one here we have final outcome is displayed through front end. The results of predictions generated by the model are presented to the user through a front end interface, which could be a web page, mobile app, or other user-facing platform. So now coming to the execution part. To execute the project, first we need to open the code folder. So here we have a folder which is named as templates. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. Next here we have the folder named as static. This folder consists of files related to CSS, JavaScript, and Bootstrap files. Then here we have .ipynp file, which is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows the users to write and execute code in individual cells, making it a popular choice for data science. Next here we have app.py file, which likely contains the information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. Then we have here signup.db file. This file appears to be the database file which is used to store the information. So now just click over here and copy the path. Open the Anaconda prompt. Type the cd command followed by a space and paste the path over here, and now hit the enter button. Now type pythonapp.py and now just hit the enter button. After running the app.py file, the Flask framework will host the application link locally at the default address and port 5000 unless configured differently. Here you can see that the link has been posted over here. Just select this link and copy this link and paste it into any of the browsers. And I'm using Chrome. Just paste the link over here and now hit the enter button. So here this is the home page for the data mining. By scrolling down below here, you can get the services for the machine learning, IDS, stacking classifier, and meta classifier. Here is the button for sign up. Just click on this button and enter your username, your full name, email ID, your mobile number, your password over here for doing the registration. I have already done the registration, so I am clicking on sign in button. Just enter the username over here and the password over here which you have created while doing the registration, and simply here click on login button. So here you can see that there is a form where you have to enter the services. Service like 3, SRC bytes as 54, DST bytes 5, SRV count, same SRV rate as 5, different SRV rate 1, designation host, same SRV as 5, designation host R error rate as 4, and now click on predict button. By scrolling down below here you can see the outcome is the attack type is normal based on the KDD cup data value. So depending upon the values they are providing over there, it will detect the stack type whether it is normal or not. By clicking on the about button, here you can see that there are many different graphs, and based upon these graphs we have used many different algorithms which is calculating their accuracy precision score over there. Let's click on the KDD cup button. So you can see that there is a button for sign on. Just click on this button and you can successfully log out with this. So now coming back to the conclusion part. In an ever-changing digital environment characterized by increasingly sophisticated cyber threats, the hybrid intrusion detection system provides a forward-thinking and efficient security solution. By utilizing feature selection for accuracy, ensemble learning for dependability, and optimizations for effectiveness, it remains at the forefront of cybersecurity readiness. This holistic strategy highlights its capacity to enhance network security and protect valuable data resources from a diverse array of cyber threats. So here we have completed with our project. Thank you.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.